Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so without wasting much time, I will be directly moving on to our lecture. In the previous lecture, we have stopped at question number 1F. I have not fully solved that question. I have given or stated the theory regarding the question number 1F. So let us come to the question. Question number 1F. What does the question number 1F says? We needed to find out the question number 1F. In question number 1F, we needed to find out the information regarding the focal length had been given. The image distance had been given. Okay, so the question number F1F had some parts. Okay, so let us see what are the subparts. Okay, so we have discussed the sign conventions regarding the concave and convex lens. Okay, so using those proper sign conventions, we will be trying to solve the problem which are given in the question paper. So in the question 1A, it has been mentioned that the diagram, there is a diagram given below. I think the question paper is with you, all of you. So just see the question. There is a diagram given below which shows an image is formed at a distance of 36 cm from the lens. So what information do I get? So we are talking about question number 1 subpart F. Okay, so what are the informations given here? The information regarding this question has been given that the image is formed at a distance of 36 cm. So image distance is denoted by the letter V. Image distance V is equals to how much? It is 36 cm. Okay. Now if you see the figure, the image has been formed on the other side of the lens. So it is actually behind the lens. It is a real image as because it is inverted in nature. So obviously the image distance will be positive in nature, 36 cm and positive. Another information regarding the problem has been given, the focal length of the lens. So focal length of the lens has been also mentioned. Focal length is denoted by the letter F. It is written as 12 cm. So for a convex lens, in the figure you can see that it's a convex lens. As the image is being formed on the right side and it is an inverted image, so you can obviously say real and inverted image are always formed by convex lens. Okay, so convex lens have a positive focal length. So remember this point that image formed by the convex lens are always real and positive. So note this point. Whenever you get to see real images are always formed by convex lens. Okay, so whenever you are seeing that a real image has been formed, you can assume, even if it is not mentioned in the question, it to be a convex lens. Fine. Now let us see what has been the question asked about. So the question says, the first part, question number 1F, part number 1. Question number 1F, part number 1. So we are solving question number 1F, part number 1. What does the question say? Let us see. The question is saying the position of the object on the left hand side should be. So what we have to find out? We have to find out the position of the object. That means we have to find out the object distance, which is denoted by the letter U, and this is what we have to find out. So you know our equation, lens equation. What does it states that 1 by F is equals to 1 by V minus 1 by U. So this is our lens equation. 1 by F equals to 1 by V minus 1 by U. Now putting the value of this in the lens equation, what we get? See, so focal length has already been mentioned. It is given as 1 by 12. 1 by 12 is equals to 1 by V has also already been mentioned, 1 by 36 minus 1 by U. So taking U onto this side, it is coming as 1 by 36 minus 1 by 12. LCM turns out to be 36. Okay, so 1 minus 3, it means minus 2 by 36, which turns out to be minus 1 by 18. I think all of you have noted the calculation at this point. If not, please pause the video and note down the calculation. I'll be just rubbing it off. Okay, so what is the value of the focal length? Then the focal length turns out to be, so 1 by, sorry, not focal length, object distance, 1 by u turns out to be minus 1 by 18. So what is the value of the u? The value of u turns out to be, so we are solving problem number question of 1F subpart 1. The value of u turns out to be, so 1 by u is equals to minus 1 by 18, or u is equals to minus 18. So u image, the object distance comes out to be 18 centimeter. Okay, now see, it has been said that there are 4 options. So 18 centimeter. Now the focal length is 12 centimeter. So just let me draw the figure out for you. It will be easier for you to understand. Let me just draw the figure. I think you have noted this red lighted, the theory written in marked in red colored pen. Okay, so what is the figure? The figure points out that we have a principal axis. This is our lens L dash. Okay, so from this point we have, this is our f on, this is our f on this side, and just let me extend the line on both the sides. What do you get? This is our 2f and this is our 2f. So now see, I can say that the f has been given as 12 centimeter, is it? So if this is 12 centimeter, then obviously this distance turns out to be twice f, means 24 centimeter. Now our object distance is 18 centimeter. So obviously the object must be lying somewhere in between this range, 24 centimeter to 12 centimeter in this range. So see, let us see the options. The position of the object has been said. The position of the object on left hand side. So this is the left hand side of the lens. The position of the object, option 1 says between 12 centimeter to 30 centimeter from the lens. 12 centimeter to 30 centimeter. So I think 12 centimeter to 30 centimeter does not lie in the figure. Let us come to option 2, beyond 24 centimeter from the lens. This is also cancelled. Option 3 regards 12 centimeter to 24 centimeter. Yes, so this is our answer. The object, this is 18 centimeter. The minus signs comes, why? This is because the minus signs comes due to the, as the object is on the left hand side of the lens. So the object will be lying in between 12 centimeter and 24 centimeter. So question number 1F, answer is, question number 1F, answer is option 3. Question number 1F, answer is option 3. Okay, so I think the problem is clear. Okay, the next part number 2, subpart 2, what does it say? The subpart 2 asks, what is the power of this lens? Now see, so there is a formula regarding the power of lens. Now let me just make it clear to you all, what do you mean by the power of lens? What do you mean by the power of lens? And I think everybody knows this. See, lens, what does a lens do? It either converges a beam of light or diverges a beam of light. The extent to which, so I can write it down like this: power of lens can be regarded as the extent to which a lens can converge or diverge a beam of light is its power. So this is actually the physical concept. What does the power means? Power means the extent to which a lens can converge or diverge a beam of light. Now mathematically the power can be expressed as the reciprocal of the focal length. Mathematically the power can be expressed as the reciprocal of focal length. So power P is regarded as the reciprocal 1 by f of the focal length. Now f must be taken in meters. Okay, so be careful here, f must be taken in meters. And if we take focal length in meter, then obviously the SI unit of power is diopter, D-I-O-P-T-R, diopter. In short, it is written as symbol is D. So this is the formula for power of lens. So this is the formula for power of lens. So if you want, you can note it down. It will help you in solving the problem. Okay. So now let us come to the calculation. The question asks, what is the power of the lens? Fine. So the power of the lens turns out to be like this. So if I just erase it off and let me see what is the power of the lens. It turns out to be, if you have not noted down the formula, please pause the video and note down the formula. So P will be equals to, now this focal length is 12 cm. So 12 cm means 12 by 100 meter, isn't it? Okay. So it's 1 by f means 1 by 12 by 100. This 100 goes up. So this turns out to be 100 by 12 diopter D. So cancelling it out, it turns out to be 25 by 3. Okay. So okay, the focal length was positive, so obviously the power will also be positive. If the focal length is negative, the power will be negative. Remember this thing. If the focal length is positive, then the power of the lens will be positive, and the focal length is negative, the power of the lens will be negative. So power of convex lens, we may note it down. Let me just write it at the corner of the board. Power of convex lens, it is always positive, whereas power of concave lens, it is taken as negative. So please note these few facts, these are very important. Okay. So 25 by 3 diopter, this turns out to be, let me see what are the options. So option 1 says negative. Whenever you see the negative, minus 8.33, the first option is cancelled. Second option is 8.4D. Third option is 8.33D, and fourth option is minus 8.4D. So obviously the third option comes out to be, this is plus 8.33D, because it's a non-terminating decimal. 3 8s are 24. 1 comes down, then again 1 0, 3 3 is 9, and the division continues. So question number 1F subpart 2. 1F subpart 2. The answer is option. This is also option C. So question number 1F. Let me just erase it out. Question number 1F subpart 2. This is also option number 3. So the answer is 8 plus 8.33D. Fine. So I think this is clear. The third question, we have already solved this out. The object distance with sign convention is, we have already solved this out. It will turn out to be minus 18 centimeter. So question number 1A subpart 3. 1A subpart 3. This answer, it is also this is answer option number 1. Option number 1, and the answer was minus 18 centimeter. Answer was object distance u equals to minus 18 centimeter. So we have solved this already. So please note down the answer. Okay. Now what does the next question says? Question number, so I think I have noted down. Now question number 1F subpart 4. What does the question says? If the lens is replaced by another lens of the same type but focal length 15 centimeter. So now the focal length is 12 centimeter. So the question says that the lens will be of the same type, means convex lens, but the focal length becomes 15 centimeter. Then What are the given options here? See, the size of the image decreases, size of the image increases, size of the image remains same, information is insufficient to conclude. So let me just discuss another theory here. So I think you have noted down the facts written on the board. If not, please pause the video and note down the facts. Else I am just rubbing it off. So I am coming to question number 1F, subpart 4. 1F subpart 4. So what does this subpart 4 asks? If it is said that we are replacing the lens with another lens of the same type but focal length is 15 cm. So focal length is greater than the previous lens, the original lens. Now here we will be seeing another formula, very important formula, the formula for magnification. What is the formula for magnification of a lens? Denoted by the letter M. Now magnification, the formula is given by, there are two formula. Either it can be taken as image height by object height, or it can be taken as image distance by object distance with proper sign. Okay, so here I stands for image height, O stands for object height, and U and V, you know, V stands for image distance, U stands for object distance. Fine. Now see, so what has been said, if we take the lens of same nature but we are taking the focal length of the lens to greater than the original case, focal length is 12 cm, instead of 12 cm it is 15 cm. So what happens to this, what happens due to this change in the focal length? You see, if the focal length is greater, now see, we have noted that the power of the lens P was 1 by f. Now if this f increases, the power of the lens decreases. What does this mean? Power of the lens decrease, this means that the image that is being formed at a certain point, it will be shifted a little bit backwards. So if I consider this, okay, the principal axis, if the, say suppose for a particular focal length, the image forms at this point, image converges at this point. If the focal length is increased, now if the focal length is increased, then what will happen? The image will converge, the power of the lens goes down. Power of the lens goes down means it will not be able to bend the light as much as it is now. So if I increase the focal length, in that case the light will be converging at this point a little bit further, a little bit back, it will be shifted a bit back. Okay, so now what happens? What happens here? Actually, you can see from the figure that the image distance, see, the image distance increases. Previously the image was here, now the image forms out to be here. So the image distance increases, V increases. Now what happens if V increases? If the V increases, let's see here, if the V increases, then obviously the magnification M increases, isn't it? If the image distance increases, the magnification M also increases, isn't it? Okay. So with this knowledge, I think you will be able to solve the question. It has been said the size of the image decreases. Obviously, this will not be the correct option. Size of the image does not decrease. Yes, the second point, the second option says the size of the image increases. Obviously, this is the answer. The size of the image will increase. So question number 1F subpart 4, option is 2. Size of the image increases. Fine. So this is your formula. Okay, so I think the theory regarding the lens has been clear to you, and also the questions I think you are able to understand by seeing this discussion. Now we will be quickly moving on to the question number 2. So this was the question number 1, subparts of question number 1. Okay. Now let us come to the question number 2. Okay. So just quickly let me rub off the board. I think you are all enjoying this video. So now the question number 2. So what does the question number 2 says? So question number 2 subpart A. Question number 2 subpart A. Now the question number 2 subpart A, what does it say? The usable form of mechanical energy. The usable form of mechanical energy. Option 1 says elastic potential energy. Option 2 says kinetic energy. Option 3 says gravitational potential energy, and none of the options. Remember, mechanical energy. What is mechanical energy? Just let me briefly review it. What is mechanical energy? The energy possessed by any body around you due to its position of rest or of motion. Due to its position. It may be of rest or in motion. Due to that rest or in motion condition, every body possesses some energy that can be regarded as mechanical energy. Now mechanical energy has two forms. Mechanical energy has two forms. Remember, kinetic energy and potential energy. Kinetic energy, this is the energy associated with the motion of the body, whereas this is the energy associated with the rest condition of the body. Now remember this thing always. We cannot utilize this potential energy directly. Whenever we want to use the energy, mechanical energy, we have to first convert this potential energy into kinetic energy, then only we can utilize the mechanical energy present in our body. So your option says, so question number 2 subpart A, answer will be, the right answer will be option number 2. So this is option number 2, kinetic energy. So we can remember this thing, kinetic energy is the usable form of the mechanical energy. Clear? Okay. Now let us quickly move on to question number B, subpart B. Question number 2 subpart B. 1 horsepower is equal to, this is also a theoretical question. 1 horsepower is equal to, I think you have read it in your book, 1 horsepower is equal to 746 watt. So this is turns out to be option 4. Question number 2 subpart B turns out to be option 4. 1 horsepower turns out to be 746 watt. Okay, so it is clear. Okay, fine. So today we will have to stop here, as time is not permitting us to go further. We will be continuing with the lecture. Please do support us. With your support, we can further move up and keep on posting videos like this and help you in your progress of science. So till then, till the next lecture, please be with us, and thank you for viewing this lecture, also supporting our channel. Thank you, take care, goodbye, tata.